Welcome to GE HealthCare's Low Flow Anesthesia video series. I'm Lisa Nolan. When a patient undergoes anesthesia, the anesthesia provider is constantly monitoring the patient's end-tidal oxygen, end-tidal anesthetic agent, and flow rate. Manual adjustments to these parameters will be made to meet the patient's uptake and demand to help ensure safe and effective anesthesia, especially when using lower to minimal fresh gas flows. These manual adjustments can increase the anesthesia provider's workload, which can become time-consuming and take away from patient care. What if you had a tool that could automatically adjust your fresh gas concentrations to quickly achieve and maintain target end-tidal oxygen and end-tidal agent concentrations, regardless of patient changes in metabolic status? Then end-tidal control may be your solution. This video will discuss the optional end-tidal control software found on GE HealthCare's ACES CS² anesthesia delivery system. Let's get started. What is end-tidal control? End-tidal control is an optional gas delivery mode where the clinician sets the target end-tidal oxygen and target anesthetic agent values. The system monitors the end-tidal oxygen and end-tidal anesthetic agent values and adjusts the gas composition and total flow to maintain the set targets. There are clear advantages to using end-tidal control: simplified management of fresh gas flow and volatile agents, reduced burden and workload for anesthesia providers. End-tidal control gives you more than a 50% decrease in machine interaction per patient, more time for other patient needs and operating room activities, peace of mind for avoiding potential hypoxia or overdosing of volatile agents. With manually controlled circle anesthesia systems, there are conventional hypoxic guards that control the oxygen percentage in the fresh gas flow and not the circuit FiO2. This could result in hypoxic levels of inspired oxygen. GE HealthCare's ACES CS² end-tidal control contains an intelligent hypoxic guard, since the oxygen percentage is controlled at the patient level by automatically compensating for the metabolic rate changes, ensuring targeted end-tidal values. End-tidal control also helps with knowledge gaps in circle anesthesia systems due to the dilution effect of rebreathing. With circle anesthesia systems, the greater the difference between fresh gas flow and minute ventilation, the greater the difference in set versus delivered concentrations of agent and oxygen. The end-tidal control algorithm automatically adjusts the fresh gas flows to meet the targeted end-tidal oxygen and anesthetic agent concentrations, taking into account the differences between the fresh gas flow and minute ventilation. End-tidal control may also help with some of the challenges involved with titrating anesthetic agents to meet desired expired anesthetic agent levels during induction, maintenance, and emergence phases of anesthesia, or what is also known as the peaks and troughs of anesthesia. Prior to initiating end-tidal control, a controlled airway, such as an endotracheal tube or a laryngeal mask airway, should be used. The ACES CS² anesthesia delivery system should have a supply of oxygen and balance gas to enter end-tidal control mode. A CareScape airway module with end-tidal control capabilities should be installed and warmed up. A full test checkout should be completed prior to use. It is important to note that end-tidal control cannot be used with halothane, enflurane, a non-circle circuit, cardiac bypass, alternate O2, and air-only modes. To enter end-tidal control, select ET control from the fresh gas panel and select Start. Once end-tidal control is selected, the anesthesia provider will need to enter the target end-tidal oxygen, end-tidal anesthetic agent, and minimum flow setting. The system monitors end-tidal oxygen and end-tidal anesthetic agent values and adjusts the gas composition and total flow to maintain the set target values. The minimum flow setting safeguards the patient by maintaining at least the minimum set flow delivered to the patient. Increasing the minimum flow does not affect the speed of change to achieve target concentrations. With end-tidal control, there are safety mechanisms in place to help clinicians protect the patient. The safety mechanisms include the delivery of increased flow when temporary issues arise, such as a leak. End-tidal control will automatically resume when the issue is resolved. Another safety mechanism is automatic exit from end-tidal control when an issue arises that requires clinician interaction or a condition that cannot be resolved during the case, such as an airway module calibration. When this occurs, the system automatically exits ET control and resumes fresh gas control. After an automatic exit, the anesthesia provider will need to manually re-enter end-tidal control. Additionally, there are checks that occur before end-tidal control begins and will continue to run while in ET control. The end-tidal control fresh gas sample check guards against incorrect delivery due to faulty airway module readings. The end-tidal control system check and the end-tidal control leak check guard against incorrect delivery due to sample line issues such as leaks. Lastly, the end-tidal control supervisor is an additional safeguard to ensure the system is able to control gas and agent delivery to meet the targets. Understanding low-flow anesthesia using end-tidal control on the ACES anesthesia delivery system is as easy as that. I'm Lisa Nolan with GE HealthCare. Thank you for joining our discussion on end-tidal control.